All right, let's take a look at a solution for the single linked list object-oriented programming problem. So for this one, this is basically just the copy from the problem statement. I made obviously some significant changes and just basically turned it into, moved things around and bulleted everything, and turned this into what to me is more like a spec to um, implement some code with. So I'm going to just go off of this and basically just kind of run down the list and just start implementing these things um, according to the rules in the spec. This one I don't actually have any tests written. Yeah, so we're just going to go off the spec for this one and submit it and cross our fingers. Cool. All right. So starting at the top. So for this challenge, write two classes. Write a class called node. So here's our first one. Still have to navigate it a little bit, and then write a second class called SSL. Okay, so node, write a class called node that will be the nodes that the linked list creates and uses to make the list. It should have two methods, init and repr. So dunder init, def dunder init should take self. Oops. Self. There we go. Okay. So its inputs are the value to be added to the list, and its attributes are going to be value and next. So I'm just going to copy this down really quick just so I can have it accessible right here. Okay, so this is for init. So the inputs are a value to be added to the list. Let's call this object, obj for short. And then the attributes are going to be value, self.value equals object, and self.nxt for next equals none. Okay, cool. That's init. And I think, you know what, actually, I want to just be able to, I won't do that. Okay, never mind. And then repr, we just want to return essentially an f string, which I just turned into an f string in the notes there. So def dunder repr takes in self and return the value. This will be self.value. Cool. Now let's just play around with our node class real quick. Should get an error because we're expecting a object. Yep. My node equals node my node. Okay. And then we could say hello. The value hello. And then let's just look at dot value and dot next. Cool. So for when we just print it out directly, we should expect to see what repr returns. When we print out the value, we should expect to see the object, and when we print out the next, we should expect to see none for now. Cool. Okay. So that's the first class done. Second class is going to be have a bit more going on here. Write a second class that should be called SLL that has 3 methods: init, push, and show. Okay, so init is just going to have 3 attributes. Obviously, it'll take in self. So 3 attributes: start, end, and count with none, none, and 0. And I'm actually just going to copy this. Okay. We'll pull this down, and we'll say this. We'll get rid of that. And these are all going to be self.start, self.end, and self.count. Equal those respectively. Cool. All right. So that's init. I'm just going to kind of do this so I know where I'm at. I'll move this partition around so I kind of remember where I'm at. Okay. So push takes a single arbitrary value. Arbitrary just means of any type. Cool. So let's def push here. You know what? I want to just copy this stuff down again. There we go. Oops. Def push takes in self, and it takes in an object again. So single arbitrary value. The process is it will increment the count by 1. So self.count plus equals 1 plus equals 1. And it'll create a new instance of node and add it to the end of the list. And I'll do this, and add it to the end of the list. And then to add a new node to the end of the list, in the previous node, set the value of next to the node. Okay, so we'll create a new node. We'll call this new node equals node object. So remember, our node just takes in an object, right? So this is going to create a new node. Yeah. So it creates a new instance of node and adds it to the end of the list. Okay, so we need to think about when the we just initialize SSL, so I'll just comment these out for now. So SLL. My SLL equals SLL. When we just initialize it, start and end are none. So what we want to do here is have different logic for when start is none. Like right now, there's no elements in this single linked list. So we want to have a different channel of logic here. So I'm just going to say if self dot start equals none, I'm going to want to say self dot start equals new node. and self.end also equals new node. So this is adding the first node because self.start equals none, right? So we want to set start and end equal to the new node. The second channel of logic will be an else, adding all, which is the logic for adding all other nodes. With this one, oops. What we'll do is we'll leave we'll leave self.start alone, and we'll set self.end, which is of type node. We just made that object. It's a node, so it has the property next. So we'll set that property to new node, and then we'll set it to the new node as well. So the new self.end will be this new node, right? So this is going to add in essentially a new node here. Cool. And the third method, so that's the end of this method. So the third method, show, will print all nodes from beginning to end of the list. The show method will not be tested in the final solution, but it's useful for debugging. So I'm actually just going to skip it for the sake of keeping the video at a reasonable time. So let's just submit this and see what we get. Cool. All right. Hopefully that was helpful. Yeah, have a good rest of your day. Bye-bye.